Hari Om. Recently, we have derived the expression for capacitance due to a parallel plate capacitor. We also have seen what will happen if we insert a dielectric inside a capacitor. Now, through this PPT, let us see what will happen to the capacitance and other quantities if we insert a dielectric in a capacitor with and without battery. That is, if the capacitor is already charged and it is disconnected from the battery or potential source, and then if we insert dielectric, what is going to happen? And if the capacitor is currently being charged, that is, it is in connection with the potential source or battery, and then if we insert the dielectric, what is going to happen? So let's see. So first of all, let us revise the capacitance due to a parallel plate capacitor without any dielectric and without any battery. So just simply we have a charged capacitor in which there are two seats like this. They are charged to Q0 and minus Q0. The area of the capacitor is A, separated by a distance of D units. So the charge on the capacitor is Q0. Electric field between the plates is E0, and potential difference between the plates is V0, represented by V0. That is, V0 is equal to E0 into D. This is an important formula. We will be using this in further down the slides, and using the relation capacitance is equal to charge by potential difference, capacitance is represented by C0, which is equal to Q0 by V0. This is the case of without dielectric and without battery. We will be using these symbols to represent different quantities as we proceed further. Now let us see what will happen if we insert a dielectric without any battery connection. That means capacitor is not connected to battery, but we insert a dielectric in that region, as you can see here. So since the capacitor is not connected to any other source, whatever charge we had provided it, initially it was charged to Q0. So whatever charge we have provided it, it remains, because charge can neither be lost nor be gained. So whatever charge was provided, initial charge was Q0, and the present charge, that is after inserting the dielectric, remains Q0. So charge hasn't changed even if we have inserted a dielectric. But as we have already seen in some previous slides, the electric field in the region will become E0 by K. What was E0? E0 was the original electric field, that is the electric field which was present when dielectric was not there, and K is the dielectric constant of the medium. So electric field has decreased by K times. Now using the expression for electric field, potential difference will also change. As you know, potential difference is electric field into distance, and the value of electric field here is E0 by K into D, and as we have seen in the previous slide, E0 into D is V0. So the potential difference between those two plates is the original potential difference divided by K. So we can say that potential difference has also decreased. Now what is the value of capacitance? Capacitance is given by charge by potential. The present charge is same as initial charge, so Q is replaced by Q0 and V is replaced by V0 by K. So calculating, our capacitance will become K times C0, and C0 was the original capacitance when there was no dielectric. So on inserting the dielectric, now the capacitance has become C, that is K times C0, which is the original capacitance. So capacitance has increased by K times. Now let us see what will happen if we insert a dielectric in a parallel plate capacitor which is connected to a battery, that is it is still in charging mode. So here we have a parallel plate capacitor with a dielectric, and let us connect it to an external potential difference source or a battery source. So since as you can see here, in both the ends of the parallel plate capacitor, the potential difference is V0. Since we are providing an external potential difference, this potential difference is constant. So here the constant quantity is going to be potential difference between the plates. It will stay V0. That is, whatever was before inserting the dielectric will still remain after inserting the dielectric. So potential difference is not going to change. Now as you know that electric field is potential difference divided by distance. So if potential difference has not changed and distance has also not changed, why will electric field change? So electric field will also be same as the original one. Now this is the important part. Charge on the capacitor will increase. Initially it was Q0, but now in this configuration the charge will become K times Q0. Why is it so? Think a bit. When we insert a dielectric, the electric field in the region should decrease. The electric field in the region should decrease. That is, it should become E0 by K. But here it is not decreasing. So what has caused the increase in electric field? Imagine it in such a way that, imagine that we don't have any battery source, and if we insert the dielectric, electric field will decrease E0 by K. Now if we insert a battery source, the electric field will again become E0. So what increased the electric field? So electric field has to be increased. How is it increased? By increasing the charges on the plate. If the charges on the plate will increase, electric field will also increase and it will regain its original value. Hence, the charge on the capacitor in this setup is K times the original charges. Now using this, you can calculate the capacitance. As capacitance is given by charge by potential difference, so charge has increased K times, so K times Q0 instead of Q. But since potential difference has remained unchanged, so we will replace V with V0, and Q0 by V0 is C0. So the present capacitance will become K times the original capacitance, that is C0. Alright. So we have seen that even if we insert dielectric in a medium with or without battery, if we are inserting a dielectric in a parallel plate capacitor with or without battery, capacitance is going to increase no matter what the condition is. So with this, let us stop here today. We will proceed to the next part in the next video. Thank you.